till they disappear and mix with the water, to be carried back again to the warm ocean from which they first started. In Switzerland the glaciers cannot reach the sea, but they move down into the valleys till they come to a warmer region, and there the end of the glacier melts and flows away in a stream. The Rhone and many other rivers are fed by the glaciers of the Alps, and as these rivers flow into the sea, our drop of water again finds its way back to its home. But when it joins itself in this way to its companions, from which it was parted for a time, does it come back clear and transparent as it left them? From the iceberg it does indeed return pure and clear, for the fairy crystallization will have no impurities, not even salt, in her ice crystals, and so as they melt they give back nothing but pure water to the sea. Yet even icebergs bring down earth and stones frozen into the bottom of the ice, and so they feed the sea with mud. But the drops of water in rivers are by no means as pure as when they rose up into the sky. We shall see in the next lecture how rivers carry down not only sand and mud all along their course, but even solid matter, such as salt, lime, iron, and flint, dissolved in the clear water, just as sugar is dissolved without our being able to see it. The water, too, which has sunk down into the earth, takes up much matter as it travels along. You all know that the water you drink from a spring is very different than rainwater, and you will often find a hard crust at the bottom of kettles and in boilers, which is formed of the carbonate of lime which is driven out of the clear water when it is boiled. The water has become hard in consequence of having picked up and dissolved the carbonate of lime on its way through the earth, just in the same way as water would become sweet if you poured it through a sugar cask. You will also have heard of iron springs, sulfur springs, and salt springs, which come out of the earth, even if you have never tasted any of them, and the water of these springs finds its way back at last to the sea. And now, can you understand why sea water should taste salt and bitter? Every drop of water which flows from the earth to the sea carries something with it. Generally, there is so little of any substance in the water that we cannot taste it, and we call it pure water. But the purest of spring or river water has always some solid matter dissolved in it, and all this goes to the sea. Now, when the sun waves come to take the water out of the sea again, they will have nothing but the pure water itself, and so all these salts and carbonates and other solid substances are left behind, and we taste them in sea water. Some day, when you are at the seaside, take some sea water and set it on the hob till a great deal has simmered gently away, and the liquid is very thick. Then take a drop of this liquid and examine it under a microscope. As it dries up gradually, you will see a number of crystals forming, some square, and these will be crystals of ordinary salt, some oblong, these will be crystals of gypsum or alabaster, and others of various shapes. Then, when you see how much matter from the land is contained in sea water, you will no longer wonder that the sea is salt. On the contrary, you will ask, why does it not grow salter every year? The answer to this scarcely belongs to our history of a drop of water, but I must suggest it to you. In the sea are numbers of soft-bodied animals, like the jelly animals which form the coral, which require a hard material for their shells, or the solid branches on which they live, and they are greedily watching for these atoms of lime, of flint, of magnesia, and of other substances brought down into the sea. It is with lime and magnesia that the tiny chalk builders form their beautiful shells, and the coral animals their skeletons, while another class of builders use the flint, and when these creatures die, their remains go to form fresh land at the bottom of the sea. And so, though the earth is being washed away by the rivers and springs, it is being built up again out of the same materials in the depths of the great ocean. And now we have reached the end of the travels of our drop of water. We have seen it drawn up by the fairy heat, invisible into the sky. There fairy cohesion seized it and formed it into water drops, and the giant gravitation pulled it down again to the earth. Or, if it rose to freezing regions, the fairy of crystallization built it into snow crystals, again to fall to the earth, and either to be melted back into water by heat, or to slide down the valleys by force of gravitation, till it became squeezed into ice. We have detected it, when invisible, forming a veil round our earth, and keeping off the intense heat of the sun's rays by day, or shutting it in by night. We have seen it chilled by blades of grass, forming sparkling dewdrops or crystals of hoarfrost, glistening in the early morning sun, and we have seen it in the dark underground being drunk up greedily by the roots of plants. We have started with it from the tropics and traveled over land and sea, watching it forming rivers or flowing underground in springs, or moving onwards to the high mountains or the poles, and coming back again in glaciers and icebergs. Through all this, while it is being carried hither and thither by invisible power, we find no trace of it becoming worn out, or likely to rest from its labors. Ever onward it goes, up and round the world, taking many forms and performing many wonderful feats. We have seen some of the work that it does in refreshing the air, feeding the plants, giving us clear, sparkling water to drink, and carrying matter to the sea. But besides this, it does a wonderful work in altering all the face of our earth. This work we shall consider in the next lecture on the two great sculptors, water and ice. End of Lecture 4. This recording is in the public domain.